Welcome to episode 298 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm all right, Rob. How are you doing?
Doing all right. Do you want to put in a plug for your latest C++ Weekly video? I know it's been getting a lot of views, right?
Yeah, I just thought I'd pull up the stats just out of curiosity. So I did an episode called Break the ABI to Save C++, which I haven't gotten any hate mail yet directly towards me. And it's been up since, what's today? Today's Wednesday, so it's been up for 48 hours. I've got 11,000 views so far, which is a little over 2 times my normal view rate.
Okay.
So yeah, we'll see what happens with that.
Yeah, and it's obviously something we've been talking about a lot on this show for a while now. And we were talking right before the show how we might try to have someone with the opposing viewpoint on soon.
Right. Yeah, I mean, our regular listeners may have noticed that I have been conducting an informal poll for the last several years. Pretty much every guest I ask, and they all say, we haven't had anyone say, no, we need ABI stability for our project or whatever.
Right. Okay. Well, at the top of every episode, I like to read a piece of feedback. And on that subject, this tweet is from Nick Gully. And he wrote, CppCast, how about some new gear? A ceramic mug with a giant ABI on the side for us to mull over breaking. And I kind of like that idea. I might put that together. Yeah.
Oh, that's terrible. Yeah, like a party. Everyone smashes their ABI mug.
Wasn't there a book that had it was titled Steal This Book or something like that? We could have a mug and say break this mug, write ABI on the other side, something like that maybe.
I think Weird Al, one of his more recent releases also was Steal This Song or something like that.
Oh yeah. All right. Well, we'd love to hear your thoughts about the show. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com. And don't forget to leave us a review on iTunes or subscribe on YouTube. Joining us today is Loïc Joly. Loïc is a C++ coder, speaker, teacher, and expert. He represents France on the ISO C++ Standardization Committee and is also a member of the committee drafting the next version of the MISRA C++ standard for safety-critical systems. In addition to developing in C++, he has a special interest in teaching it and spreading good practices across the community. He's a frequent speaker at meetups and conferences and teaches at Telecom Sud Paris. Since he joined SonarSource in 2018, he has worked on static analysis for C++, both specifying rules to help other developers and having the fun of implementing them. Loïc, welcome to the show.
Hello, welcome, and thank you for having me.
And so do you think that we should be willing to break the ABI for C++ in the near future?
Well, I must say that every concern about the ABI are a little bit foreign to me because I always rebuild my code from source. And I'm mostly a Windows user when it's typical to package the libraries at the same time as you package your product. I don't work with shared libraries across different products. So for me, ABI is almost a non-existing concern. And yet I have to pay for the things that I don't really use. So
Oh, that's an ironic way of looking at it with the, don't pay for what you don't use mentality of C++. Well, and it's interesting, too, since you mentioned that you're a Windows developer, because when I released this video, I got a lot of feedback from people that are like, what are you even talking about? We don't have ABI stability.
And I saw some of those comments. I was very surprised by that since it's been such an ongoing discussion. There seem to be a lot of people who are just still very unaware of what it is and why it's important.
And I think that now in Windows it happens because previously when you switch from a version of Visual Studio, you just had to recompile everything. And now they try to introduce stability between different versions of Visual Studio. So I think it's a little bit moving into the direction of stable ABI, even if it's not totally there yet.
Yeah. But it still seems like almost every Windows developer just assumes if I upgrade my compiler, I have to rebuild the world. They still assume that. So, I mean, if everyone's already in the place to rebuild the world, then let's just go ahead and rebuild the world. That's what I say.
I know that I may not have to do it, but I will feel more confident if I do it anyway.
Right. Yeah. Right. It's like the very first thing you do, right? You have a weird bug that you can't diagnose. What do? Rebuild. Right? Because you just assume there's a link problem somewhere at some point.
Yep.
All right. Well, Loic, we have a couple news articles to discuss. Feel free to comment on any of these, and we'll start talking more about the work you're doing at SonarSource, okay?
Sure.
All right. So this first one, speaking of Visual Studio, the 2019 16.10 preview is, I believe, out now. And this is their changelog announcing that it is going to be, the STL is going to be C++20 feature complete, which is pretty exciting that we already have at least all the library features implemented in one of the major compilers.
And there's an ironic problem here.
What is that?
I've been following this along on Twitter, and I got some clarification from Victor on it.
Mm-hmm.
There's basically a bug in std format where one part of it accidentally relies on locale, and std format is supposed to be locale independent. They want to change that as a real quick fix to C++20, theoretically. But Visual Studio has already promised ABI compatibility with their standard library implementation. So if they were to fix that in the standard, Visual Studio can't fix it, and it would still be stuck with locale dependence.
Yep.
Interesting.
Yeah. Anything else either of you want to highlight? Anything you're looking forward to being able to use in the new version?
Well, just one point to me, it's a little bit strange to focus on full library support and full language support, because now I think that both of them are entangled in some way. And it's what really matters for me is full support, period. But I know it's a good step. I'm pretty happy. I'm excited by it. But I really think that I'm not sure to which point full library supports totally work without full language support.
They're pretty close, though. If you look on like CPP reference, their Visual Studio's language support is really, really close for C++20 also.
What are they still waiting on? Do you have
I don't recall. I'd have to
okay. All right. Well, in other news, we have an update for another one of the compilers, and this is GCC 11.1 is being released, and they're also announcing a lot of great support with C++20. They're changing their default language version up to C++17, which is great. And it sounds like, did they specify exactly how far along they are with 20, or they're just saying they're making good progress?
They say go to their status page for some of these things. I went to CPP reference to look at their version of the compiler support chart for C++20 GCC. And it's interesting because GCC is, let's see, they're in the green for every single language feature except modules.
Oh, okay. Yeah, that's very good.
Yeah. Which is interesting because Clang had the tendency to be ahead on these things. But if you look at this comparison chart right now, GCC and Visual Studio are way ahead of Clang for C++20 support.
Yeah. Interesting.
It's a pattern that I've noticed also, and I'm even a little bit worried about it because it seems to show that there is a kind of slowdown in Clang. It used to be first for language features, and now it's. I really rely on Clang for my daily work, not only as a compiler but also as the libraries that we use as a basis to do the static code analysis. So I mean, it's a wonderful tool for that. But the fact that they are lagging behind Visual Studio and behind the GCC is not a good sign. I hope it's just some punctual reasons, and not a global pattern.
Yeah.
Because right now, for example, for modules, I don't see many stuff in Clang at all.
Yeah,
I mean, even GCC, they are not complete with modules, but they have the basic is done, and there are some few corner cases to handle, but they already are pretty good.
Yeah. I'm sorry. I'm just scrolling through this list of comparisons again. Yeah, and some of the things that are like lambdas and unevaluated context, which sounds small but is huge to library developers. It doesn't even list as partial support in Clang yet.
Hopefully they'll be catching up soon.
I do want to comment on one other thing before we move past GCC.
Sure.
That one of these notes in the GCC 11. So first of all, I was so confused. Apparently 11.1 is the first official release of the GCC 11 series.
Oh, there wasn't an 11.0?
Not that I can find. Maybe I'm nuts, but I think it's the first official release in the GCC 11 series. But they mention here hardware-assisted address sanitizer support. Apparently, the 64-bit ARM target has the ability somehow to do hardware-assisted address sanitizer support, so it uses considerably less RAM. It's in a testing phase and can only be used with the Linux kernel right now, but I found that very interesting.
Yeah, sounds interesting. Okay, and then the last thing we have is meeting C++ survey results, and this was a survey on the most popular features of C++. And what's interesting is he shows last year's survey results side by side with this year's results, so you can see how some features might get used more over the past year as developers have had more time to get accustomed to using these features. And I think actually there were a couple that look like they have gone down just a little bit, but most of the usage of various features seems to be pretty consistent from year to year. So I thought that was interesting.
Yeah, that's one of the main things
to highlight. Oh, go ahead, Jason.
One of the main things that stood out to me was that the histograms are almost identical from year to year, which I just really didn't expect that. But yeah, just a couple of little things here. There was more people reporting that they're not using C++ 14, which is maybe just a different group of people that responded to that question. I don't know.
Or they're upgrading to 17, right?
I guess maybe they misunderstood the question and they're like, no, I'm not using 14. I'm using 17. I don't know.
Right. Okay, so Loïc, we've talked a lot about different static analysis tools on the podcast before, but I don't think we've discussed SonarCube before. So do you want to start off by maybe just telling us a little bit about the SonarCube analysis tool?
Well, I'm not going to talk only about SonarCube, but about all the tools that we do at SonarSource, which are basically 3 tools, but they work together. And if you want to have a full story of what we propose, we have to talk about all of them. So we have Sonarlint, SonarCube, and SonarCloud. Sonarlint is a tool that runs in the IDE, so it's your first line of defense. And then we have SonarCube and SonarCloud, which work more in the continuous integration phase. So it's SonarCube is something that is self-hosted, while SonarCloud is something on the cloud. But basically, it's the same set of features, and it allows you to analyze your code during pull requests, for example, and to block a pull request if it's not meeting some quality criteria. And you can also see the history of the code, how many new issues you have introduced, and this kind of stuff.
Sorry, please go ahead.
So yes, it's our goal is to be tightly integrated into the development cycle to make a tool for developers. So that's why we are in the inner loop with the IDE, and we are in a slightly outer loop with pull request, and that's where we are positioned.
With Sonarlint, you said that's an IDE tool. Is that available for different IDEs as a plugin? Which ones does it support?
Well, it supports different IDE depending on the language. I'm going to focus on C++ here because that's why we're there. So for C++, we support Visual Studio. And since very few, maybe 1 week or 2, we also support C-Lion. So it's brand new. So, and basically it's the same rules that run inside of the IDE and inside of SonarCube, SonarCloud. The main difference is that some rules that requires full project knowledge are not going to work in the IDE, because on the IDE we work on a translation unit basis.
I'm kind of curious, like what kind of tools require full visibility of the project?
Like an unused function. If you
That's
don't have a full project, unused function, it's obviously not doable.
That's interesting, because I just spent a week or so with one of my clients removing about 100,000 lines of code, actually, that were unused. considerable performance compile time savings for us on that project.
So
And it's not so easy to detect that something is unused in C++. It's very tricky because you have some functions that are not used, but you still don't want to remove them. For example, if you have a class which is a container, maybe you want to have begin and end, and even if the user is not using them right now, you still want to provide begin and end because it just makes sense to make your class compatible with other similar classes. So it's this notion of unused function is not clear cut, I would say.
So that is an interesting one that came up in the project I was working on, because some of the functions were used, but only by the test suite. So I had to disable the test suite for some of my detection, because if it's only used in the test suite for our particular case, I didn't care. I wanted to remove it.
Makes sense.
So does your tool actually say it is completely unused, or can I get a report that says it is used only in this one place or something like that?
No, it's only going to tell you if it's totally unused. We try to, how to say, we are not providing a tool to help you explore your code. We are just focusing on raising issues and trying to explain the issues. So, for example, if we have a rule about the rule of 5, so we are going to point the class and we are going to say, okay, look, here you have defined a destructor, here you have defined a copy constructor, but you forgot something. So we are going to show you all the interesting locations that are useful to understand what's the problem. Okay. But you are not providing a tool to manually explore your code base.
Okay. So as you said, we're obviously on a C++ podcast. We're going to focus on C++. But do you want to tell us about what other languages SonarSource analysis works for?
I think we have 27 languages, something like that. But the main languages we focus on are Java. It started as a Java company, mostly. So we are very well known in the Java ecosystem. And then we also have tools for C#, Python, JavaScript, TypeScript, and I forgot many of them. But, yeah.
That many, okay.
I think I mentioned the most important ones, and if I forgot some of them, some of my colleagues are going to kill me tomorrow, so we'll see.
I actually, coincidentally, as we were discussing this interview, one of my friends shared with me an issue that SonarCube had found in their C# code base. That was, oh no, I can't remember the detail of it, but it was particularly insidious. Oh, it was something equals minus something instead of something minus equals the other value. And it was particularly insidious in their code. And SonarCube found it, so that brought it to my awareness recently.
And I know that, for example, since we are very well known in the world of Java, some people who work on the JVM also used our tool on C++ and discovered interesting stuff in the JVM. So,
kind of bring it full cycle that way.
Yeah.
I'm curious, I see here that it says, because I brought up the Sonarlint page after you mentioned that, and looking at the CLion plugin, it says Sonarlint is open source. It's an open source project?
Well, Sonarlint, which is the integration inside of the IDE, is open source, but the core of the C++ analyzer is closed source.
Okay.
However, it's available for free in Sonarlint. So if you analyze code in the IDE, it's available for free. It's also available for free if you do SonarCloud on an open source project.
Okay.
But if you want to do SonarCloud on a closed source project, or if you want to do C++ analysis in SonarCube, you have to pay for it. And so it's based on the number of lines of code in the project.
Oh, that's interesting model. Okay.
So are there like specific types of bugs that the SonarSource analysis tools are particularly good at finding?
Well, we have a full range of issues in many different directions. And so I think that at least from my point of view, where we have a lot of value compared to other tools that exist, or at least when we try to invest to have a lot of value, is about rules, not only about detecting a bug, but rules that push forwards good way of programming. So let me give you a classical example. You can have a rule about double delete or about missing a delete and memory leak. It's pretty hard to have this kind of rule. Everybody has it, but to have a good rule for that, it's pretty difficult because you have to follow all the paths inside of your code. And then as soon as you have a function call, you don't know in which condition it could be called. So you have to do very complex stuff. But we are developing C++. What we should do is not do any raw memory allocation. We should use unique pointers. And it's pretty easy to do a rule which detects just that you allocated memory without storing it immediately into a unique pointer or shell pointer or a class like that. And it adds, well, this is almost so simple that you don't need a static analysis to do it. But there are some other rules of the same category where by pushing forward for the good practices, you prevent bug indirectly. And at the same time, you also try to have rules that detect the bug when you didn't follow those good practices. But I really think that this is one differentiating point between our tool and, for example, compiler warnings, because compilers now are doing lots of warnings, very interesting ones. But they really try to warn only when the code is almost certainly broken. We try to raise issues when the code is badly written. So that's the difference.
Really seems valuable, yeah.
And as I mentioned, for example, we have some rules about rule of 5 or rule of 0. The code could perfectly be correct without following those rules, but it's so much more simple to read code that follows them that we do that.
Okay. It's interesting. I think you said you aim towards a rule like don't allocate memory without immediately putting it into a unique pointer or something like that. And just out of curiosity, do you also have rules that try to detect misuse or abuse of smart pointers, like manually calling delete on the pointer returned from a unique pointer, or unintentional copies of a shared pointer or something like that?
I don't think we have the one you mentioned, but for example, we have one rule which is you should not pass a unique pointer by const reference.
Oh, okay.
Because if you do, you should just pass the pointer. Your function will have a broader interface and it will be just the same.
Right. Yeah, exactly.
So we have a few rules like that.
Okay, interesting.
Yeah. I already asked about the other languages that SonarSource supports. Does it run on other platforms as well? I know you mentioned it, the Visual Studio plugin. Does it? So I don't know. It runs on Windows. Does it run on Linux and Mac as well?
Yes, the core of SonarSource runs on Windows, Linux, and Mac OS. And then for Sonarlint, it really depends. For example, I know that for Java, it runs on Eclipse and VS Code also. And I don't have the full matrix of which language is supported in which IDE. But yes, basically, we try to support the major ones, obviously.
Okay.
And a point I forgot to mention, an important difference between Sonarlint and SonarCube, SonarCloud is Sonarlint is basically more for the developer himself, while SonarCloud and SonarCube are more for a team. So for SonarCube and SonarCloud, you have some rules that are going to be followed by the full team. And so you have one settings of rule that is going to be shared on each pull request. And there is also in Sonarlint what we call a connected mode, which is if you also run SonarCube or SonarCloud, you can synchronize with it. So that, for example, if in SonarCube you say that a rule is a false positive for you, or it's not an issue, you decided that, okay, in this case, I don't want this rule, we will stop reporting it in the IDE also.
Oh, nice.
That is interesting.
So those tools are not totally separated. They really work together.
So you said SonarCloud is available for open source projects. Is that right?
Well, it's available for open or closed source, and it's free for open source.
Free for open source. Okay. Is there any limitations on the open source analysis?
It's exactly the same version.
Okay. I'm just thinking about how to go about enabling it on this other project that I've been working on.
Yeah, how
which
easy
open
is it
source.
to set it up for an open source project if you're interested?
Well, if you want to set up SonarCloud or SonarCube, you have to add some step into the build system because, as you know, C++ build system are awfully complex. So what we do if we have a program that is going to eavesdrops what happens during a build and save all information about which file was compiled with which option, which include path and everything. So it just detects when we call the compiler itself, and it saves it in a file. So now we have all this information, and we can use it to correctly analyze the code with the right parameters. So the way to configure this analysis is first to modify slightly your build system so that when you build, you are wrapped inside of this additional program that will save the data. It's like a compilation database of Clang, if you know this, except that it can be created with any kind of build system. And then we use this kind of compilation database to do the analysis in the second step and to upload the results on SonarCube and SonarCloud.
Okay.
So you mentioned
it's a little bit of work to integrate it into your CI, but it's once you are used to it, it's just a few lines of script.
Do you have like a quick start? If you're like, you're using a CMake project, then this is what you need to do kind of documentation?
We have some quick start guide, yeah, and we have some sample projects that you can look at.
Nice. So you mentioned in your bio that you while working on the static analysis, you specify rules and helping other developers implement them. What kind of work goes into specifying new rules for the SonarSource analysis tools? How do you go about that?
Well, it's sometimes it's very complex, and there are some rules which took us more time to specify than to develop. Okay. It can seem surprising, but I even wrote a blog article on one of them because it took so much effort that I said, okay, I'm not going to waste this effort just to write a rule. I'm also going to write a blog article to explain what were the different steps in the rule. It's a rule which seems simple. Should you pass by copy or by cross-reference?
Oh, okay.
It looks simple. It's you probably have your own algorithm in your head about what should you do. But if you try to implement this kind of algorithm automatically, then it becomes much more complex. And for example, how do you decide if a type is expensive to copy or not? What's the criterion? Is it just the size of the type? If you look at CPP core guidelines, for example, you will see that they suggest having a rule like that, only focusing on the size of the type. But you can have small types which are expensive to copy because they own external resources. But if you say, for example, that you want to look at the copy constructor to see what it does, it means that you have to have it available. So it goes against what we like to do is to be able to analyze a translation unit in isolation. We try to avoid full project analysis if we can, because it's much more expensive, it's more complex to set up. So if you are just looking at one translation unit, you may not have the body of the copy constructor, so you may not know if it's doing some expensive operations or not. So we try to develop this rule, and we developed it maybe 3 or 4 times, and right now we are in the process of upgrading it once again. So because it's very simple. It's already difficult, in fact, to have guidelines that are for human being. But when you try to apply the guideline by a computer, it's every dark corner you have to tackle it and to decide, okay, am I going to raise a violation here or not? And we try very hard not to raise false positives, because false positives are a pain for the developer. It's just going to waste their time. But at the same time, sometimes we need to do something, because it's very easy to do a static analysis that raises no false positive. It's obviously simple. Just raise nothing. So we want to raise some stuff, and it's hard to find the good balance between, in some cases, raising some false positive but not raising too many of them.
Yeah, well, I mean, on the upside, if you did raise no errors at all, you'd also have the fastest static analysis,
Yes.
I think.
And I could deliver it with the fastest C++ compiler, fully conformant C++ compiler, which just outputs, sorry, not enough resources to compile this file.
Right. Which is pretty much true. You include a header file, but anyhow.
And otherwise, the one interesting point about rules is where we get the inspiration from the rules. Yeah. Because there are two parts. There is one, you need to know, okay, I want to do a rule for this problem. So first you need to discover the problem, and then the second part is, okay, now that I know I want to do this rule, what should be these limits, the special cases, and how to tune it. So I spoke about the second part, but the first part is quite interesting too. So we are using our own knowledge of the language, of course. We are C++ developers, so when we do something that doesn't work great, we try to remember it so that maybe we write a rule about it in the future. And it also works the other way. So when we have a rule and in our own code, it's triggered too often. And when you say, okay, trying to follow this rule would make the code less clear. Okay, maybe we screwed up with the rule. We have to change it. So that's the good point of dogfooding our own product. So for example, we had one about trying to detect when a lambda is called immediately. Because if it's called immediately, we can capture everything by reference. It's not going to dangle, so it's safe to capture everything by reference. And there were some cases, for example, when we in the first implementation we had when we were calling an algorithm from the library, we said, okay, we are passing the lambda to a function. We don't know if it's going to be called immediately. But in fact, most of the algorithms of the standard library are just going to call the lambda and not store it in anywhere. So we had to special case those algorithms, for example. And it's through experience on our own code that we discovered this. So there is this part, and then the part of inspiration. So inspiration comes from our experience too. It also comes from new versions of the standard. So recently we spent some time reading what was new in C++20 and tried to think if it would deserve some new rules. And usually those rules come in two categories. One is, okay, there is this new stuff in C++20, but it's dangerous because of that and that, so we should warn against it. Only in the dangerous cases, of course. And there is also the other direction, which is, okay, there is this new stuff in C++20. It allows people to write code differently than it was used before. So maybe we should detect a pattern in all C++ to suggest to upgrade to the new feature in C++20. So this is one source of inspiration. Of course, CPP core guidelines are also another source of inspiration, but those guidelines are very much written for human beings. Even if they gave some tips about how it could be automatically analyzed, it's just a first step. So we cannot directly implement a C++ core guideline most of the time. We have to use it as a source of inspiration to make the rule, but it's not a direct translation. And also, a big part of C++ core guideline requires the user to write the code in a very specific way, which is not the typical way of writing C++. Everything which is related to JSON and this lifetime safety with decorating the types that you pass everywhere. We don't consider that this is typical way of writing the code, and we are not in the business of telling people to write the code in a specific way so that we are going to be able to analyze it correctly. There are tools that do that, and they're pretty useful if they work in a very narrow domain when people have the capability to pay the price to do extra work to have the tool give better results. But this is not what we try to be. We try to be a tool for all C++ developers and working on existing code. So we cannot do that. It would not be well accepted by all users. So that's why the CPP core guidelines, we cannot do all of it. And for the part that we do, we have to do some transformation between the way it's described and the way we implement it. And then we have also other sources. For example, there is MISRA, which is a coding standard for the automotive industry mostly. Basically, it's for safety critical software. So it was the current official version of MISRA is MISRA C++ 2008. So it was a different C++ at the time. And we are working now on upgrading it to C++ 17.
Okay.
So I don't know exactly when it's going to be out, but we try to modernize the rule, and I think we have a very good balance now in the people working on MISRA between people working in the safety critical industry and people having a very good knowledge of the language to try to make them match, and not safety critical and modern C++ are not in opposition. They can work hand in hand, and I think that's what we're trying to do. Yet those rules are not going to be rules applicable in every situations, because safety critical code requires extra caution, and some of the rules could be generic. Some of them are probably going to be specific for safety critical software. So
if you're using any of the SonarSource analysis tools against your code base, do you have options with like what rule set you want to use? Like, I want to use the MISRA, or I want to use the core guidelines, or whatever else?
While we have some flags on the rules that explain where they come from, we have the possibility to create some rule set, but now for MISRA, we don't have a full coverage of MISRA C++ 2008, and we didn't think it was interesting to develop this full coverage. So right now, we don't have a profile for safety critical code. When we work on the next version of MISRA, that's probably something that's going to happen. Okay. And then we have basically one profile which goes SonarWay, which is the set of rules that we believe should be applicable in all circumstances. And then we have other rules that could make sense in some contexts that are not enabled by default, but the user can enable them if it makes sense for him. Let's say, for example, I don't think we have it now, but we are discussing about adding a rule about west const or east const, or just the same const. You see, it's typically the kind of rule for which there is no right or wrong.
Right. There's a couple of things you mentioned about rules that you do have or struggled with that caught my attention, like the deciding when to copy something, pass by copy or cost by value. So do you actually, in your analysis, do you actually go and look and see what the copy constructor does? You don't just rely on is trivially copyable or something like that?
Well, currently for this specific rule, we don't look at what the copy constructor does.
Okay.
For some other rule, we do some, we look in what it does. For example, we have a series of rules about constness. For example, we have some rules that say, okay, this variable is not modified, it could be const. But to know if it's modified or not, we don't only rely on the prototype of functions. So even if you pass by non-const reference, if we can see the body of the function and if we can detect that it's not modifying the object, we are still going to raise the violation, telling you should have this. Well, first you should pass it as a const reference, and it should be a const variable.
Okay. It just caught my attention because I noticed one project I'm working on that some tag types, which are just used for overload resolution, right? Like just passed as a parameter to a function just to say, choose this version of the overload or the constructor, were in some cases accidentally being passed by const reference instead of by value, even though they were just empty types entirely. And in a templated type used thousands of times across hundreds of C++ files, that actually had a notable impact in the code base to just make that pass by value in that case.
Yeah.
The compiler didn't have to push pointers onto the stack.
Actually, for this rule, we in the first version, in some cases we said, okay, you're passing by reference, but you could pass it by copy. Mm-hmm. But we had lots of issues. When we do a rule for that, we test it on, I don't know, maybe 30 or 50 open source projects. We run it on LibreOffice, we run it on Clang, we run it on the Linux kernel. We run it on many big open source projects, and we try to see the results. And for this rule, there were so many cases when people pass by reference, they could have passed by copy. And we said, okay, there is value in passing by copy, as you said, but the value is not as great as in the other direction. So right. Because if we just raise an issue in these cases, it's going to be too noisy. So we are not going to do it.
Well, maybe you could upgrade the rule to say if it's a completely empty type, then always pass it by value.
Maybe that's good. That could be an option, yes.
The other thing you mentioned of when to alert on a default capture by reference for a Lambda with immediately invoked Lambdas or passing them. That's one of the rules from effective modern C++ that just is too strict, because I believe in Scott says there to never do a default capture by reference, but it basically eliminates all the useful use case, all the interesting use cases for Lambdas, like immediately invoking them or passing them to algorithms. So I found that interesting that you had to put in like a special rule to check for algorithm usage.
Yeah, the first version of the rules about Lambda didn't care about if the Lambda was immediately called or not. And the feedback we looked, we saw on different projects, and our own project told us that we really needed to make this important distinction.
Yeah. So do you, when users set ignore a rule to be ignored on SonarCloud, do you keep those statistics and say, hey, there's like 100,000 users that are all ignoring this rule. Maybe we need to take a closer look at it.
Well, it's we are starting to do it. It's we are starting to get this kind of feedback from the users. Right now, it's I think my colleagues who work on other languages are more advanced than we are on this point. It's SonarCloud is more recent than SonarCube. And at first, we also had to make sure that by doing that, you are not sharing secrets from the customers.
Right.
So we had to be careful about what information we collect. Mm-hmm. So now we do. I know that we do it. I don't know the details, and we clearly want to use this information. Especially, we introduced during this year lots of effort about rules around security, mostly for other languages, a little bit for C++ also, but mostly for other languages. And we wanted to know what was the feedback of those. So I know that people got a good look at it, if it was detected as being a false positive or if it was deactivated, trying to understand what happened.
It just feels like that could be so fascinating to look at that, because on one hand, you want to be like, 1,000 people are ignoring this. They clearly can't all be wrong. But then sometimes I'm guessing you're going to look at it and be like, wow, 1,000 programmers are dead wrong.
I know they made an experiment for some very safety-sensitive embedded software. They had the requirement that the software had to be developed twice and run twice in 2 different parallel hardware on the real system, and just to make sure that it was rock solid. And those teams that developed the program had a contractual obligation not to talk with each other. Mm-hmm. Yet, in some cases, they discovered that there was the same bug at the same place.
Wow!
Because both of them were developed by human beings. Mm-hmm. And had mostly the same education, so it's easy to. I mean, some places are naturally error prone, so they had the same bug in the same places in some cases.
That's really interesting, because it's like the Apollo guidance computer or whatever was also like written, or no, was it? Anyhow, some of the NASA mission stuff was written twice by 2 different contractors, and then the systems voted to see, what was the correct thing to do at that moment. I'm curious.
And the problem is twice is if they disagree, what do you do? So if you should do it 3 times. So there could be a majority. That's
a Minority Report plot right there, right? A whole Tom Cruise movie for those who didn't catch that. But anyhow.
Gosh, that movie is old now.
It is old now, yes. It'll just make you feel old to think about how old that movie is.
You did mention some newer security rules, I think you said, for C++. What are some of those newer rules?
Well, basically, we are focusing on, there's several, like always, we go in several directions and we see what we can do, where we can bring some value to the user. So for security, one of the not so complex to develop, but I think quite interesting rule was one about when people are using in C, when they're using memsets, to try to delete some memory so that even if someone gets access to the memory of the process, they will not see a password that could be stored there.
Right.
But of course, memset could be optimized away.
If you never read back that memory.
If you never read back the memory, which is what you do usually when you do this kind of stuff, you just want to scrap it away before doing something else, so you are not going to read it back. So we have a rule that detects that and says you should use the special, it's a memset_s, I think, a special function that cannot be optimized away that does the same work. So we have this rule.
Okay.
We have a bunch of rules around the POSIX functions, which are, it's mostly C because, it's so much easy to make a buffer overflow in C than in C++. I mean, char*star. Why char*star? So we have, there are lots of POSIX functions that work with char*star, and that takes 2 arguments, a buffer and a size, and we try to detect if the buffer size is consistent with the size which is passed to the function.
Right.
And this is clearly one domain into which we have a way to improve again, because it's in the category of rules which are hard to do because you have to follow the data across the execution path. And it's never going to be, it's been proven to be impossible to be perfect in those cases. It would be like solving the halting problem to do that perfectly. So we know we're never going to be perfect, but we try to improve. And also we are going to try also to improve on the way we report the issue to the user, because we are not totally great on this point right now, but still we have these rules that try to detect when you are using some POSIX functions and you are not doing it well, and you might have buffer overflows. And then we have also some security rules around some uses of cryptography libraries or hashing libraries that compute safety critical hash. And so for those rules, it's mostly those libraries have lots of API, and some API are safe, some are unsafe, and we detect if people use the wrong API or didn't. For example, you create a cryptographic context, then you should set some option before encrypting something, and you forgot to set those options. So that's the kind of stuff we detect.
Wow.
Yeah.
Some of those sound like really advanced, like you said, like trying to make sure that the size matches the buffer that was created. You have to do all kinds of code analysis to figure out when this buffer was created, how big it was, is it still alive, whatever.
Yeah, I mean, the day we will have solved this problem perfectly, but it's probably never going to happen. I will retire before it happens. We have some things that give some good results. We have a lot of way to improve, but yes, it's a really hard problem.
So where do you see how SonarSource or Sonar, the tool suite, fits in with things like address sanitizer and Clang Tidy and some of the other tools that are available out there right now?
Well, actually, to do this kind of analysis, we rely on the Clang Static Analyzer, which is one of the engines behind the Clang Tidy.
Okay.
We extended it. We might tune it a little bit differently, but it's the same basis. And if you compare to address sanitizer, it's totally different because we don't work at runtime. And I think one of the biggest advantage of not running at runtime is that we detect problem even if you don't run into them right now in your test suite. So that's even if your test suite is not very good and it's not going to trigger these specific conditions, we could detect that in some very corner case situations that could happen on the customer side, but that's not happening in your unit test. You could have a memory allocation issue.
Okay.
So I really think that address sanitizer and what we do are complementary stuff. You should have both on your programs. Yeah.
But you said you use the Clang Static Analyzer for the backend. So if I run SonarCloud, if I run my project on SonarCloud, am I going to get all the Clang Tidy rules as well as your rules run, or are you going to run just your rules?
So we don't integrate directly Clang ID.
Okay.
We are based on Clang, but we don't integrate everything from Clang ID. So some of the rules we have are inspired from Clang ID because we just had the same idea, but we didn't try to integrate all of Clang ID. So we designed the rules ourselves. We looked at every source possible, of course, but we didn't just copy paste Clang ID.
No, sure. No, I mean, I just didn't know how much of it was inherited, not necessarily that you copy and pasted it in there or whatever.
And we also have some rules that are just based on Clang warnings, because some of those warnings could be very useful. And also our analyzer is capable of analyzing code written for Visual Studio, for example. So especially for those users, having some of the warnings from Clang might not be easy. So we also integrated some of them.
Okay.
Do you want to tell us some more about the process of implementing some of these rules? So you talked a little bit about how it's all based on Clang. Do you want to go into any more detail?
Well, we basically have 3 strategies to implement a rule. One is there is already a warning in Clang which does the work. So we just reuse it. So it's the easiest case. Unless you want to do something 99% like Clang, but not 100%. So you have to give up this easy process. Then there is the rules which needs to follow the flow of execution. So typically knowing that a specific value, a specific variable must have a specific value at a moment in the code. So those ones are based on Clang static analyzer. So we developed static analyzer checkers using the framework provided by Clang to implement those rules. And then the third type of rule is rules that are based on the structure of the code. So typically rules about rule of 5. You don't need to simulate the execution to be able to detect a violation of the rule of 5 or of the rule of 0. And so those ones are based also on Clang, but on ST matchers. So it's the same technology that is used in Clang ID, just that we developed other rules.
Okay.
If I get a rule violation from one of your tools, how much information am I going to get? Now, what I'm specifically thinking of is you said a lot of the rules are inspired by the core guidelines. I'm just curious, like if I get a rule violation, am I going to get documentation that says this is a bad idea because such and such, and you might want to read this core guideline, for example?
Yeah, basically every rule we have a documentation where we try to explain why we have the rule. We also try to explain what pattern we detect, which might not be exactly the same as why we have the rule, because we could have a why which is generic, and inside of this generic purpose we detect only a few specific patterns. Then we almost always have an example of bad code, an example of how to rewrite the code so that it's better. And if the rule is inspired by some external sources like CppCast guideline or MISRA or CERT, we are referencing them.
Cool.
And in the rule itself, say we try to have what we call secondary location. So the rule is located at one place in the code, but we also try to reference other places of the code that are interesting to understand why the rule is triggered. So for example, if you, let me try to find a real world example. I'm not 100% sure, but for example, for the rule about the fact that you could pass an argument by const reference, maybe we are going to highlight where this argument is going to be used, so that you can easily check that you really want to pass it by const reference, and that it's not that we could have made a mistake in the rule. It's more like maybe you didn't pass it by const reference because right now you're not modifying it, but in your mind you plan to modify it in the future or something like that. So it's always better to have information about more context when you read the rule to really understand if it's something that you want to act on or not.
Okay. Well, Loïc, it's been great having you on the show today. Is there anything else you want to talk about before we let you go? Obviously, listeners can go and check everything out at SonarSource.com, right?
Yes. No, I don't have any specific ideas right now.
Okay. Where can listeners find you online?
Sorry?
Where can listeners find you online? Are you on Twitter, blog, or anything like that?
Well, I'm old school. I don't. I'm not on Twitter. I have a few blog articles into the blog of SonarSource. Okay. I'm mostly joinable by mail. That's the main way to do it. I mean, that's the way it worked in the 90s. Why shouldn't it work again today?
All right. Well, we'll be sure to include those links to your blog and everything on the show notes.
Yeah. And if you speak French, you might also follow a few. I quite often participate to French meetups, there is the CppP conference that started in 2019 that was cancelled in 2020 for some reason, and we plan to start it again in 2021. And I was a speaker there, but it was also in French. So I like to speak in French because it allows me to reach a different kind of people than when I speak in English. So
Sure. All right. Well, it's great having you on the show today, Loïc.
Thank you.
Thanks for coming on.